0.246 kilometer square. Okay. Now the Kennedy surface is orthogonal. The SES curve number, SES in hydrograph, low base flow. The loss we use 17 for as a curve number. Transform we use 50 minutes. Okay, for the subbasic 3. Now we can see that after we have input the subbasic 3 downstream, we can see we have a solid black thin line directly linked to the outlet. That means this subbasic 3 is directly discharged to the outlet. Okay. Now this is for the subbasic. Okay. For the ridge one, we may also have input the parameters. Okay, for the ridge and for every ridge. Okay. Now for the downstream, the ridge one, the downstream of the ridge one is the immediately downstream is the junction. Okay. Now the routine method we may use the masking gum, crunch. Okay, masking gum. Which you will have learned later on. Okay. Loss gate method. Okay, we select line. Okay, we select line. For the routing, okay, we need to input the length, the slope, manage roughness, the bottom width, side slope for the ridge. Okay, the length. Okay, for example, we can measure the length here. For the subcatchment 1, we can measure this length, this to this. Okay. Double okay. Oh, this is the measurement. Okay. This, which is about 202. Okay. Now we can input here for the 202. The slope, okay, you can calculate or evaluate the slope from this from the ISO altitude line here. Okay. Now, for example, in this we assume it to be 0.08. Okay, for the slope. For the managed end, okay, for the managed end, the managed roughness, you can look for the managed roughness. Okay, in the table, which you have the table in the open channel section. Okay, we suppose this is 0.015. Okay, for example. Now, if you estimate that the channel will be, the stream will be appear to be a trapezoidal shape. Okay, you can use this trapezoidal shape for the channel. And for the bottom width, we supposed to be 1 meter. The side slope for the is about 1. Okay. Now this is for the masking gum crunch method for estimate the routing for the stream ridge 1. Okay. For the ridge 2, now the same way we may select the downstream, which is the junction 1. Okay. We suppose this subcatchment area drains to the junction, and this subcatchment drains to the junction, and then drainage through the ridge 3 to the outlet. Okay. Now the routing method using the masking gum crunch. Okay. Now the length we can also measure subcatchment here. Okay, here we may measure. It's 429. Okay. 429 meter. Slope. Managed end. Bottom width. This is the estimate value. Okay. The assumption value. Now this is for the ridge 2. Okay. For the junction. The junction do not need to input any specific parameter. Okay. you just need to select the downstream, okay? Immediately downstream is a reach free, okay? So then we select the reach free. Now this is for the junction. For the reach free, and the same way we select the downstream is the outlet, okay? The routing method, the mask income can, okay? For the reach, we may also measure the length again. From this one, okay, from this to this to this to this, okay. It's about 120 meters, okay. Now we may input 120, slope 0.008, minus n 0.015, bottom width will be larger, okay, larger, 2 meters, okay. Now this is for the reach free, and the outlet, okay, do not have any downstream. This is the outlet, okay. So then this is you input the component parameter for the basin, okay, for the catchment area. This is a simple illustration, okay. If you have learned how to do this one, you can also know how to do for the complicated one, okay. Now this is for the basic model. After we build up the model, okay, we need to add another component, okay. One is the meteorological model manager for this for the precipitation events, okay. Now, for example, we have build up the models and new models like the Mach1, and then we close. And we have the meteorological models here at the Mach1. Now we may need to define the parameter for the Mach1, okay, the meteorological model. Now the short wave we select none, okay. The precipitation, you can either choose the SCS storm or the specified hydrograph, okay. Now in this project, okay, we may use a specific hydrograph. Now because we have obtained the rainfall data, okay, from the HK Observatory for the adjacent rain gauge, okay. So that we may use the specific hydrograph. Now the unit is metric, okay, in mm per hour. There is no snowmelt, and suppose there is no evaporation, okay. If you the evapotranspiration is in a large number in the reservoir, okay. For the land area, the number is quite small, so that you can neglect this one, okay. Now you may choose the they're asking you whether the what is the Mach1 applied to, okay. Is it applied to the Long Ha Wan Basin? Okay, we select yes. Okay, we select yes, and then and this is the methodological model. Okay, if we click on the sub content for the Mach1, we can see we will have the we may choose the sub-basin. Okay, the gauge for the sub-basin. Okay, now. At this moment, okay, we haven't built any gauge, rain gauge, okay, so that we may build up the rain gauge for indicate the specified rains, okay, the rain drop. Now we do use the time series data manager and select the precipitation gauge here, okay, precipitation gauge, and we click the new gauge, okay. Now we only need to create one gauge because we only have one adjacent gauge data, okay. After we have built up the time series data precipitation gauge, we may click on the gauge 1, okay. Now it may asking you to select the data source is manually in entry, okay, which you have obtained from the HK Observatory, okay. the units is in incremental millimeter. Okay, incremental means that the number you input that stands for the hourly, okay, rainfall for that moment. Okay? If you select the cumulative millimeter, that means you need to input the cumulative rainfall depth, okay, which you have already learned in the hydrograph section. Okay, the time interval, okay, because the you see in the HKO website we only have the hourly rainfall number, okay, so that we may choose 1 hour, okay. We may choose 1 hour here. Now, for example, 11, okay. Now we only have 1 hour, okay, 1 hour rainfall, and now the adjacent, okay, for the Long Ha Wan is the Saigon rain gauge here, okay. Now, so that in this software, we may use the site in this project. We may use the Saigon data, and after we have input some information for the rain gauge, we may choose a specific time for the rain gauge. Okay. Now we can see that this data format used the U.S. Army data format. Okay, is two words for the day, 3 words for the month, and 4 words for the years. Okay, because we use the day 11 April, APR 2015 from 0 o'clock to 30 APR April 2015 and 2015 0 o'clock. Okay. Now this is the time, and then after we input the time, they may give you the tables and indicate manually input the precipitation rates for the precipitation events for this time moment. Okay. Time period. Now we may input manually. This is just for illustration. after input, we have the rainfall here. Okay, we have the rainfall. Now we have a graph here also indicate the rainfall, the hydrograph. Okay, the hydrograph. And then after we input manually data, okay, and we click the specify hydrograph again for the subbasin. Okay, we can see that we can choose the gauge here. Okay, we can choose a precipitation gauge. For example, we choose the gauge 1 for all the subbasin. Okay, now that we have finished build up the precipitation model. Okay, we have finished build up the precipitation model. After we build up the time series data, we may build up the control. Okay, the control. For example, we call the control 1. You also can have other control. Okay, the control 1, which is talking about the simulation period. Okay, you need to simulate. Okay, for example, the start date is from 11th APR 2015. Okay, the start time is 0 o'clock. Okay, to 11:30 APR 2015. Okay, and the end time is 0 o'clock. Okay. Okay, the time interval is the simulation interval. Okay, we select 15 minutes. Okay, you also can select smaller. After you have done this, you may save the project. Okay, you may save the project, and then you need to at this step. Okay, we have built up the basic components for the simulation, and then we need to choose the simulate this model. Okay, you may find that here has some great icons here. Okay, now we haven't have any run computation here. Okay, if we select the simulation run, okay, from the compute, create, compute, and simulation run here. Okay, it may give you a window. Okay, asking you to select the name and the basin, the meteorological model, and the control model. Okay, if we select this one, we can see that we have water drop and a pump sign here. Okay, now this is for the run one. Okay, now after we check the unit and also the data input, okay, we can try to run this model. Okay, to run this simulation by clicking this one or by this the menu, clicking the compute one. Okay, we can click this this icon. Okay, we click it, and if there is no other problem or error, okay, you can have a 100% complete and finish the computing one. Okay, if there is some data which is not input, you may have some indication in the this status window. Okay, now that we finished running simulate this kind of the subbasin. Okay, the basic model. Now we can now choose the tab here. Okay, we have the component tab and have the result tab. Now we click on the result and we will see that we have the simulation runs. Okay, for the run one. When you click on the run one, you will have such lot of the components in the run one. Okay. Now for creating the global summary, okay, you will have the summary of the result for the mid run, the discharging area which is input by us manually, the peak discharge for every subcatchment. Okay. Now the volume, the total volume of the precipitation, okay, from the meteorological event. Okay. Now this is a summary, and if you click on the subbasin, okay, for example the graph, okay, you can see the in this picture, in this figure, indicate the the blue one is the precipitation, okay, which is input manually. The red one is the corresponding precipitation loss, okay. Because we have input the SES curve number for the loss, okay, so that it will have a part of water infiltrate into the ground, okay, so that this is a loss. In the bottom figure, okay, it's essentially the flow waste, okay, the flow waste, the flow velocity actually can be multiplied by the area to calculate the flow rate for the precipitation, okay. You can see that after letting the loss for the precipitation, we have the flow waste for the catchments, okay. Now, you can see in each subbasin, okay, we have this kind of the figure. Okay, for example, subbasin 1, we also have this figure. Okay, now this is for the for you to analysis. Okay, after the simulation. Okay, now for the each reach, okay, we also have the hydrograph, okay, we call it the hydrograph. The outflow, okay, combined flow, okay. The reach one is just connect to the subbasin one, okay, so that they just have the one hydrograph, okay. For example, for the junction one, okay, it may have three hydrograph, okay. It may have three hydrograph. One is comes from the reach one, this dashed line. The second one is from reach two, okay. And then this the solid line is called the total hydrograph, okay. And for the reach 3, okay, reach 3 is also the same as the junction 1, okay, the same as junction 1. Now for the subbasin 3, now you can see if we input the number, okay, we have this kind of the indication. And for the outlet, okay, for the outlet, we can see for the outlet the figure, okay. We can see also the hydrograph for the different components, okay. For different components, okay, you may see that if you use different loss method and transform method, you may generate different hydrograph, okay. The hydrograph may have a small difference, okay. You may try to make every the simulation using different method to be a similar one, okay, by discussing about what does the parameter stands for, okay. For example, what does the curve number stands for the subbasin, okay. For example, if you choosing the SES curve number unit hydrograph, what is the meaning for the lag time and for the curve number in previous number, okay. Now the task for you for discussion is to discuss this one. And for comparing the two methods, okay, for example, the reach loss routing method, okay, the routing method may have the kinetic wave, masking gun, conch, and also the kinds of method, okay. Now the subbasin, the transform method may have also a kinetic wave, SES hydrograph, Snyder hydrograph, and also the Clark unit hydrograph, okay. Now you may discuss what is the difference between this modeling method, okay. Now this is the illustration for the EC HMS program, okay. Do you have any question? Now, if you don't have any questions, okay, now this mini project you do not need to have so should be the gauge, okay, gauge. If you don't have any question, okay, now the mini project do not need to have the presentation, okay. You need to just submit the report, okay, submit the report at the end of this semester. At the end of the lecture, okay, which means it may be at the week 36. Week 36. Okay. Now this is the this is for the mini project 2. Okay. You can try to run the HMS program. If you have some questions, okay, you can raise your hand and we'll come to help you.